Hey everyone, I'm David Room, and we're back today with some more 3D mesh processing stuff. I took a little detour from the 3D mesh processing stuff to work on getting some stuff that we made in the game. That's kind of worked out, so back to checking a few other things off, and one ongoing project that I've had here that I haven't done a lot of streaming about is building some utilities for working on 3D printing my models. And I'm still kind of figuring out what pieces of functionality I need, and I'll probably come up with more once I get into actually physically printing things. But there's one piece that I kind of came up with the other day that I think it's not going to be too hard to implement, so we're going to look at that. Maybe do a little bit of refactoring and cleanup of some of the stuff that I've already implemented here on the 3D printing front. And then if we still have time and there's some people watching, I will probably just work on some other things on my space fleet checklist. So we added the engine glow capability, or technique. We'll add that to a few more ships. There's some other ships that need hard points, things like that. So yeah, all that stuff has been going really well. I feel like I have really good tools for everything now. So it's been pretty easy and pretty fun to work on that stuff. So let's just get into it here. So I have this this bench script for my 3D printing project, and we are looking at a couple of different low poly versions of ships to start building out this process. And I'll show you quick some stuff that I'm working on, or what I've built so far, and kind of look at what needs to be done next. So I have these ship models, right, and I want to print them, but printing them is going to involve taking them into pieces and printing in the individual pieces with connectors that allow me to put them together. So I'm trying to build a nice set of utilities for being able to place and then like automatically create these connectors by cutting geometry and adding it. So you know, you start implementing this stuff and then you'll start getting into situations where it doesn't work. So I implemented something that lets me make little holes and pegs as connectors, and I'll show you what that looks like, and I'll show you where it's kind of not working. So here's our low poly racan that we're going to try to print. And I know that I want to print this fuselage as one piece, and then print the wings separately, and print these fin-like radiators separately. And oh, and the little antennas too. So here we're attaching pegs to the little antennas, and then we're attaching pegs to this wing. So what we're doing is we're kind of cutting away everything where the wing intersects with the fuselage, and then adding these little pegs in. And one problem with this approach as is that I'm kind of specifying where these little pegs should be added, but depending on what is being cut against, they don't necessarily connect, so we might have to add more material, and I don't necessarily want to do that if I don't have to. So here's what the final model looks like, and I haven't added the pegs to this other wing, so we're just looking at one. But we have these antennas that have the pegs that slot in, and then we have the wing that slots in. But yeah, the problem is that we don't really have good connections from those pegs to this without extra material. And then there's going to be these situations like this where it doesn't, like the peg doesn't really match up too well with the underlying mesh that we're attaching stuff to. So what I want to do instead is I want to create and I'm going to just talk through this because it could be such a thing that this doesn't make sense. And sometimes this stuff, it's hard to picture in your head and you just have to implement it to see if it actually works. But what I'm picturing is instead of a peg here, and I have I want to be able to control the tolerance here. So I have a slightly larger hole that I'm cutting than the peg, right? So instead of a peg, I want to have a much larger sized piece that I can kind of control the size of. That instead of being a certain shape, and then cutting with that shape, we will basically cut twice with that shape. We'll cut once, and instead of doing a difference, well, yeah, instead of doing a difference, we'll do a intersection, and that'll give us this sort of like underlying shape here that we can attach, and then we'll do a bigger cut that's a difference that will give us the hole. And then we'll have more material to attach, and it should fit perfectly in with the piece that we're attaching it to. And we'll also we won't have this kind of thing disrupting the surface or need extra material or anything. It should be a little bit more foolproof. So I just need to double check and make sure that I've got intersection. Oh yeah, and then this is kind of like what the resulting parts set looks like. So this is what would go into the slicing software, and then that can be plated and printed. Let me just check Twitter here quick, and then we're going to get into it. Okay, so all right, so I'm just gonna double check and make sure that I have it's gonna disable this too. This. So we'll look at the files later if we get to it. Let's make sure this is also. And see, yeah, we're using diff here. But we're going to actually want to do something similar with intersections, I believe. And that might be something that we have to rewrite, because we're working here with a set of parts that are all either watertight or made up of individual components that are watertight. So we're generalizing these Boolean operations that usually only work on watertight things to these like sets of watertight things. And we might have to refactor some of that, but let me just check and make sure we have so we've got difference. Intersection. Yeah, see, like, for whatever reason, I never have actually used intersection, but that's actually what we need. That's actually what we need here. Let me just make sure that this intersection. Yeah. Okay, so we might have to add, because I think we're basically going to be doing something similar where based on, actually just close out some of this stuff. I'm trying some new music tonight too. We're listening to Cinematic Dark Synthwave playlist by White Bat. So that'll be fun. It's fun to try out. I like this so far. It's hard for me sometimes to find music for these live streams that is both like interesting and also doesn't like put my blood pressure up too high. Okay, so let me just check, because we're gonna do something similar. Like this diff multiple parts. Let's see, I wonder if we can just, it'd be kind of funny to go through and put like a flag here to tell it to do intersections instead of diffs. But I think that's pretty much what we want, actually. Although some of this stuff is fast enough now, I might be able to just rewrite it. And I can actually just patch in an intersection. And let me just think this through. Is this what I want? So like we're gonna intersect instead of differencing. We're gonna intersect a mesh against multiple meshes. Oh, this is diffing. Let me see. Yeah, we're making our diff multiple parts. Well, it's just going to be one. So diff. So here. Yeah, I think we might just build a new interface for this. Yeah, we're using this manifold library now, and it might be fast enough that we don't really need to do some of the fancy stuff that we were doing here anymore. And we can, I think we can do it all in the global space. And we don't want to do this. We don't need this scale thing anymore. This was kind of an old, like cutting parts with a scale factor is kind of an old thing that I was doing that is a little bit phased out now and we're not actually using. So let's just try to write it from scratch. See what we get. I mean, not from scratch. I'm not writing the mesh boolean itself from scratch, but the operation that is doing this sort of like multi-way intersection. Okay, so and actually I think this could kind of replace this. So yeah, let's make a new, let's just kind of replace this. So we'll say, let's add intersect connector. And then if we yeah, and actually I think we can reuse the same configuration because like we're describing these pegs that have a certain length, but with this intersection approach, I think we can actually just make it arbitrarily long in the other direction. Yeah, I think that actually works. And we'll have some easy test cases here. Cool. All right, let's split this right here. Let's clean this stuff up a little bit. And for people who might be new watching, I am writing Python code, and I'm using, and sort of while I'm using it, I'm building this 3D mesh processing library of my own. And it is mostly built on sort of wrappers of this library called TriMesh, and then it uses NumPy for the underlying representation of the mesh. Just uses a very simple mesh representation, and then I'm either wrapping bits of NumPy or TriMesh to give them an interface that I like better, or I'm writing pieces myself. So there's certain things that TriMesh implements in kind of a weird way that I've just rebuilt myself, and I've added additional functionality that it doesn't support. And here for these Boolean operations, TriMesh is actually wrapping a library called Manifold, which is really awesome. It is way faster than the solutions that they used before. So a lot of this mesh Boolean stuff has become much more reasonable to work on than it was before. Now let's go through here and see what makes sense to do. So I think we still want to trim against everything, so we won't have any overlaps. But this might not be necessary. So we're still doing pegs and holes. And we're just gonna take the peg connector first. Otherwise, we'll just skip and return parts. So to do. Yeah, I think like the more I think about this, I'm picturing something different where we have a much larger connector with this approach that will like have more surface area and more attachment area, but we can test this approach with the peg connectors that we're using now. So let's actually just view these, because I think the first thing that's gonna do is the pegs and holes for the antennas. And I think what we can do is just to kind of test things, we can make, yeah, so that's the peg and that's the hole, and you can see the hole is long, and I think what we can do is we can make, with this approach, we can make the peg long too, because we'll let's see, how will that work? Oh yeah, the peg will also be, the peg will be intersected against the intersected against everything that we're cutting. Yeah, okay. Yeah, though it'll be intersected against everything, and it'll be unioned, and then that will be it. Okay, here we go. So here we're doubling the length. Let's just make a flag here for yeah, and that length extra was, but see, we won't need that. Yeah, actually, I think this is going to be fine. We just want to give them a little bit of extra length here. So that's like the distance that the peg is going to come up above the, like back into the mesh that it's attached to. So actually we don't need this. Now we should see, yeah, so here's our little extra buffer, and we can actually just give this more because it's not going to hurt anything here. Okay. So now we have okay, so we have to now deal with our pegs and holes. So before in this old version, I swear I can type. Okay, in this old version, once we have our pegs and holes, we union all of the pegs and add them, and then we cut all the holes. So instead, what we're gonna do is we're gonna union all the pegs, and then intersect them against every mesh. Yeah, so maybe actually, well, might as well just keep writing it separate. I'm thinking now about just a flag here in this connector mode for like intersection mode, but it's good to not get too far ahead of ourselves here. Especially because we do have to write the intersection stuff from scratch here. So, so what are we going to do? We're going to union all of the pegs together, and then intersect the pegs with all of the parts except the part that we are attaching pegs to. And then, yeah, I'm just gonna make a note here. So like, oh yeah, and here we're unioning the pegs with the mesh, which isn't what we want to do yet. Okay. So now let's just build a big flat list of all of the meshes that we're going to intersect this with. So So my representation of a model hierarchy is just a dictionary that has sort of like named references to parents in the hierarchy, and I have functions that can kind of flatten everything out. So, yeah, it's not really the most... Oh yeah, flatten parts. Yeah, okay, yeah, this is what I want. Okay, good. Because we find the global transformations, then transform everything, and put it, yeah, that's what I want. Okay, so, and we can just take this as, no. Yep. So this is everything except this one antenna, right? This one antenna that we're going to be leaving out of the intersection. So let's go through here and convert this guy to tri-mesh so we're ready. Let's just, yeah, that should be fine. Okay, so now this is kind of where we're going to follow what we were doing in diff. Import TQD in here so we get a nice progress bar. And actually, let's see here. I don't need to flatten this. I can leave this as a dictionary. So we just have to check for components here. Now we do our intersect here. So set result is mesh dot boolean dot intersection, and just don't have to do anything. So it's going to be X LTM. Actually, yeah, we might not be able to do. We might not be able to do this. I don't think that's going to work for this, but that's okay. We'll just handle the simple case first and then go on to the more complex cases. Because this thing is going to be expecting meshes that are individually manifold. Yeah, actually, we're not going to even do this. We're going to just say just look at a single peg. So peg is peg 0, TM is peg. Okay, so we're going to intersect the peg TM with comp TM engine equals u dot boolean, which should be manifold. Yep. Okay. Now, at the end of this, we'll want to union all of these together. So this will be the Now this is trivial, so this should kind of just have a trivial result that looks really similar to our current results. Okay, so we're getting not all meshes are volumes. Oh, which kind of makes sense. So there's probably some empty results here. So we can say, like, if res.vertices.shape is greater than 0, then append it. Yeah. Okay. Okay, that's not quite what I expected. Because I would have expected the peg int results. See, I'm wondering why we still have this part up above here, because the intersection should not include that stuff that's above. Alright, well, let's just take a look and see for the cases where it did actually intersect and return something what it looked like. So Oh, I know what's going on here. Our peg is... Yeah. Our peg is not in the right coordinate system. So yeah, that's what's missing. So in add connector, these are being unioned with the mesh that they're being attached to. So before we do this diff, we have to transform so we need to find the global transformations here. Yeah, because like here too, when we do these position connectors, they're translated and stuff around, so we need to transform it into its not global space, transform it into global space. So peg transform mesh of same. Okay, now we should get something more reasonable. Whoops. Yep, there we go. Yep. Okay, now we have to transform it back. Now I have to transform it back. Yeah, see, this is what that other function was doing. It's taking care of a lot of this kind of stuff. But that's okay. We can reason about it pretty straightforwardly here. So once we have this back, then we inverse whoops. Wait a second. So it's in the global space here. Oh, I overwrote name. That's why. Okay, so we don't actually need name there. Boom, boom. There we go. Perfect. Okay, and see, at least for this case, this is like maybe not the most efficient thing we can do, but it's gonna work fine. And we can just go ahead and, I'm gonna just go ahead and wrap this up. Wrap this up into something convenient. Again, I'm not as concerned about efficiency here as just getting this working, and then we can experiment with like optimizing this later. For this case in particular, though, it doesn't really matter. So what is this going to be? Like, intersect. This can just be a list. So intersect a mesh against multiple meshes, which may each have multiple components. Because it's like, yeah, like if you had two overlapping spheres and then you ran a cylinder through it and you said, I want to intersect that cylinder against those two overlapping spheres, you would want to intersect the cylinder against the one sphere and then intersect it against the other sphere and then union those two together. I'm pretty sure that I'm thinking about this right. So this will wrap the conversion to tri-mesh and back, but you know, we'll have to do the coordinate space conversion and everything. Okay. need to carry the names of this through right now because we can check up. We're kind of working under the assumption that everything is appropriately has the appropriate properties up front, so we're not having to check for that kind of thing inside. So we can just turn this into a list right here. So after this little refactoring, it should still basically work the same as it did before. We're not adding any new functionality. And oh. Yeah. I'm gonna call this mesh against. This is mesh. Thought we might have had a little bug there for a second, but no. I'm just trying to see if it's worth. I don't think we need to convert any of this stuff up front. We can always optimize later. And this will be int m. There we go. Okay, cool. So now we're gonna do this for our several pegs. And then int. Yeah. Okay, I'm feeling pretty good now about the idea that we can basically just swap this into our original add connector function with intersection mode. So let's do that now, because the holes case doesn't change. The holes are still done the same way. This is just a different mode. So let's clean this up and swap it in. Yeah, because none of this stuff is any different. Oh, actually, yeah. It's just not even that. We still actually want to do this. So it's just if int mode. Look at that. So this is kind of cool. Like I'm adding extra material to those pegs, and it's just getting cut off because it's getting intersected. So that's basically exactly what I was hoping. Now here, let's see what happens. So here we're adding 2. Oh, fuselage 1 not found. that's not good. Okay, so we've got this working at least for the single pegs. Now, the case where we have let's just get rid of these antenna connectors and start with the wing connectors and debug this. So now, what are we viewing here? This is, yeah, so this is just the pegs and holes. Okay, but then here, okay. I know what's going on. So I'm filtering too early here because there could be things that are parented to this thing. So I need to... Wait a second. Yeah, okay, so something is going on here because... Yeah, I need to flatten first. Yeah, see, I thought this was gonna happen. So I need to flatten first and then filter. So I need to flatten parts first and then I need to filter. Yep, so here's everything that we're going to be testing against. There's the one intersection, that's what we're left with. There's the other intersection, that's what we're left with. All right, let's take a look. Oh, beautiful. Beautiful, beautiful, beautiful. There it is. Look at that. That is exactly what I wanted. Now see, if we look at this now, if we pull this out, it should be, yeah, see, and this is gonna be, because manifold is so good, so this is attached. Hi, hey Flyfox Pro, I don't know when you left your message, but Flyfox Pro says, "Hola, is this that new Halo 2 game?" No, this is not Halo 2. This is some 3D mesh processing work for 3D printing. But the comparisons to Halo are always welcome. Yeah, so yeah, because manifold works so well, you can see this is actually connected and it should be watertight and everything. You shouldn't have any funny business going on in here. And actually, let's just take a look and verify that, because you know, it actually doesn't probably matter too much for our application, but like if we grab one of these faces and start dragging, yeah, all of this is all watertight. So there isn't anything. Oh. I don't know. Maybe a little bit of funny business with some coplanar stuff, but you know, yeah, I mean, this is, I guess I'm not gonna worry about this too much. We could actually increase that length here. Yeah, actually, I think I didn't do that. No. We should make sure this stuff works. We can actually increase this length, because it's now with the intersection, it's gonna, and the beautiful thing about this approach now too is we can make these connectors bigger too, and it's not gonna goof anything up. Okay, so Flyfox Pro says, I started learning code just recently using Godot. Actually more interesting than I anticipated. Yeah, I love programming. I mean, it's basically my calling in life, since it's what I do for a career and for fun, but I would encourage anybody who's like remotely interested in, what's going on here? Who is remotely interested in programming to learn, because it's really fun. Let me just see. Yeah, see, maybe this isn't perfect, but man, it's darn close. Yeah, it's close enough. I mean, that's gonna go into the slicer and just work. Let's do some. So that was like some kind of dark synthwave. Now we'll do some LA Sunset. Yeah, this is gonna go into the slicer and it's gonna work. Don't think I don't think this is gonna be a problem. Let me just think about this a little bit. Is there a nice way to kind of guarantee a little bit more of an overlap here? If I intersected, yeah, there just isn't, because I have to intersect this piece against, or diff this piece against everything else. And then I have to intersect that against everything else. You run into problems with Booleans when you have things that are like exactly coplanar. It's better if there's bigger intersections. But really, at the end of the day, actually, you know, here's the thing. These don't really have. There's nothing that says that these have to be unioned, actually. Yeah. So I think I can do this. So there's nothing. Yeah. I actually just want to cap these. And then that, because we're working with sets of watertight parts, that's gonna preserve that property will still be preserved, and then we won't end up with extra geometry. As long as the slicer deals with it, which I think it should. Yeah, see, now we have nice clean. Let's actually just stick this into the slicer and see if it looks like it's doing anything degenerate with this, if we don't do a union there. Oh, it's in Scratch. Plate this, and what happens if we slice it? Does this look, so I'm not a 3D printing expert, but does this look like something that is not like what I want to see? And I think I see it, is I want to see this structure running around inside these. I don't want to see it. You know, if it was like disconnected or something, that would be bad. Nope, see, that's going through. Now that to me looks like what I wanted to. So I think that this is going to be good. And let's just take a look at the actual fuselage itself and see if that actually. Let's look at one of the antennas, and let's look at the let's look at the actual fuselage. So I'm still learning about, you know, how to actually print things properly, but you know, just does this look like it's doing something reasonable? And it does. It does look like it's doing something reasonable. Cool. And on this little antenna, we also have, so this, yeah, see, this is the cool thing, is like the mesh, this mesh is not like attached, it's not watertight, but the slicer is doing reasonable things as far as how that piece is getting connected. So I don't think it needs to be connected. Now, the cool thing here is what we can do now, especially with like the way the wings attach, is we can do connectors that are much bigger. So it should slide in there really nice and hold nice. Cool. Let's see here. So I started about 9:50. It's about 11:10. I think we've reached a pretty good stopping point for tonight. If this 3D printing stuff is of interest, definitely check back later. I'm gonna, man, it's been several weeks now when I said, okay, this is the week that I'm actually gonna get something printed, but I think I have just about all the pieces necessary to do that here. I need to attach some of these connectors to some of the other spots, and I'm going to try to make a bigger, differently shaped peg here for these pieces. But I think this is looking about as good as I would expect it to, and looking forward to getting started with this. Cool. All right. Well, thanks everyone for watching. Good to see you in the chat, FlyFox Pro. And catch you later.